Let us take a look at this graph. Sometimes the curve goes down and sometimes it goes up. And at certain points, it becomes flat. So here is the question. How can we tell when a function is increasing or decreasing? And more importantly, how can we determine this using calculus? Hello everyone, welcome to Ocean Cafe. Now this topic that we are going through today is actually one of the most important conceptual bridges in calculus. So I am happy that you are here with me learning these together. Now let us start off with something that we are very familiar with. So at this point, the curve becomes flat. So there is a turning point and the tangent line here has a slope of 0. So in this case, we will have derivative is equals to 0. So similarly over here, there's a turning point and derivative will also be equals to 0. Now notice this part of the graph. You notice that the graph is moving downwards as x increases. So this means that the function here is decreasing and the gradient is negative. Now over here, the curve starts to go upwards. So when the slope is positive, and we say that the function is increasing. Similarly for here, this is a down slope graph. So the key idea here is this. If gradient function dy dx is greater than 0, we say that the function is increasing. And if dy dx less than 0, we say that the function is decreasing. Now, but when we are given a function, we don't usually have the graph. So instead, what we need to do is to use the derivative to determine whether the function is increasing or decreasing. So we are going to go through 3 examples to see how exactly this can be done. Let us take a look at this first example. We have an easy functions over here. So what I am going to do is to find the derivative. So by using power rule, I am able to get 3x squared easily. Now what we observe is the condition is given, so x greater than 0. So hence, since x is greater than 0, and I do have a perfect square over here, so therefore I know that 3x squared has to be greater than 0 as well. So which means our dy dx, the derivative has to be greater than 0. So in this case, we say that it is an increasing function. Now let's take a look at the graph. If I were to sketch the graph, this is the shape of y equals to x cubed for x greater than 0. If I'm going to add the tangent, so you get to see that we do have an increasing function because we do have a positive slope. Here is the second example. So over here we have a slightly more complicated function, but we do learn how to differentiate functions like this. So what I'm going to do is to find the derivative. I am going to use chain rule. All I simply need to do, is to rewrite this as x plus 1 to the power of negative half. So from there, when I differentiate, I will be able to get negative half x plus 1 to the power of 3 over 2. Now, if I'm going to rewrite this into a positive index, this is what we get. Now, so let's take a look at the condition. So over here, we are given that x is greater or equals to 0. But don't forget, x is at the denominator. So since x is greater or equal to 0, if we take a look at the denominator, and we do know that for fraction, denominator cannot be equal to 0. So which means I do know that denominator itself has to be greater than 0. Now with this, you take a look at the function. You notice that there is a negative sign. If the denominator is a positive value, so which means combining with the numerator and the negative functions here, which means I will know that the derivative here will be a negative value. So with this, I can conclude that this will be a decreasing function. So again, let us take a look at the graph, how it looks like. So if I'm going to sketch the graph, this is the shape of the function that I get. So you can see that it is actually a decreasing function. So if I'm going to add the tangent, you will see that this is actually aligned with the negative slope. So this is a decreasing function. This is the last example, and it is the most important question that all of you will need to take note. All right, because questions like this came out very often in the national examinations. Now, for these functions, we have a fractions, which means to find the derivative, what I am going to do is I am going to use quotient rule. So using quotient rule, this will give us the answer. So I have v du dx minus of u dv dx divided by v squared. So simplifying the numerator, this will give us negative 12 over 5 plus 2x bracket squared. Now do take note of the conditions here. So over here is stated that x cannot be equals to negative 5 over 2. Right? It's simply because with this value, this will make our denominator equals to 0, which means our functions will be undefined. All right, so do take note of this here. Now, so let's take a look at this derivative. All right, how do I know whether is this function increasing or decreasing? There must be a way for us to write down the proof, and this is important. All right, so let's take a look at the denominator. The denominator here is actually a perfect square, and we do know that for any perfect square, it has to be strictly greater than 0. As mentioned, denominator cannot be 0. All right, so once I have this again, similar to the earlier example, because it is a negative value in front here, so therefore I do know that, all right, this derivative will be a negative value. So f prime of x has to be less than 0. So with this, what is the type of function that we get here? It is a decreasing function. All right, so over here, do take note, you must know how to write out the proof. So the statement here, it is really important. So do take note of the presentation. Yeah, so in summary, all right, what do we learn today? So it is important for all of you to know, all right, and be familiar with the condition. So a function is said to be increasing, all right, then we know that the gradient function, all right, the derivative has to be greater than 0. And if a function is decreasing, then we know that the derivative is less than 0. So be familiar with this condition. Thank you for watching this lesson with me. I hope you find this useful. So if this helped you, please like and share the video. So do join me in my next video. I will see you. Bye.